easiest because I'm pretty sure you knew to put stuff in standard form. The standard learning targets where it's pretty easy too because you've already did factoring. We're just going to apply factoring to quadratic equations. And then the third learning target is where life gets fun, but in a good way kind of fun. Okay, so for today, since we are wanting to talk about quadratics only, any problem that's not a quadratic, we're going to get rid of. 1's not a quadratic, that's grouping. 3 is to the fourth, 5 is to the third, 4 is to, we're only on number 2. Stop. Okay, so we've got one more factoring problem to do. Well, not just one more, but another factoring problem to do. What can I do on number 2? There's a GCF of 3, then you pay each 10 point. So it's z squared plus 8z plus 15. I'm pretty sure I'm getting black all over my dress. Let me erase what's behind me now. Is it? No. Okay, good. No. Okay, and you were saying what and what? Okay, you can have something. Even like Miss Compton, we just did that at our workshop. I agree. That's why we're going to skip a lot of them, because we've been doing it for a while. You should have it down by now. If not, we're questioning a lot of things. I know for sure that our math workshop test is going to be the Monday of Thanksgiving week. If you've decided that you're personally going to take the whole Thanksgiving week, which I really understand, if that's what you're doing, then let me know and you can have it the Friday before. Okay. What kind of gets us with like exams and stuff? Do what, dear? One that kind of gets us with like exams and stuff. Oh yeah. Well, I don't know when the exemption date's ended because it was the 17th, I think. I don't know my date. So I don't know. Oh. Okay. I only know math. That's all I got. The reason we're doing this, the reason we're factoring, you might want to write this so it all ties together for you, is that the x-intercepts can be found by factoring. So the past week or so, we've spent time and time again talking about how to find things with our calculator once we've graphed the quadratic. But you can really do it all by hand. We discussed how to find that axis of symmetry by hand, how to plug it back in and find that vertex by hand. All of the things can be done by hand. I'm not taking the calculator away from you, but all of it could be done by hand. And those two x-intercepts can be found simply by factoring. Okay, we had 2 other vocab terms that also meant x-intercepts. What are those? Jax gets the point. So, knowing me, I'm going to throw any of those 3 terms out because I just use them all interchangeably like I am somebody. Okay, so the bottom ones are different because they say solve. We also should have realized they were different, 6 through 11, because there was an equal 0. So we just factoring like we did on number 2 is not sufficient. We're going to have to keep going and get actual answers like z equals this. Okay, so on number 6, what should I do factoring wise? You can have a point. There was a GCF of 5x. We pull it out. We're left with 4x plus 3 equals 0. From here is where life gets fun. Because, again, we have factored, but we're not done. We need 2 answers. Up to 2 answers. Because it's to the second, we can have up to 2 answers. Of course you do. Yeah, you can't. I mean, same. So what we're going to do is end up setting each of these terms equal to 0. So we're going to do 5x equals 0 and 4x plus 3 equals 0. And the reason we do that is because you're thinking through math-wise. If this term's 0, well, 0 times anything is 0. If the other term's 0, 0 times anything is 0. So just one of them has to be 0. So that's why we go ahead and set them. Okay, so my first answer is x equals 0. What's my second answer? Every group can have a point. So those are our two answers, meaning if we were to graph this parabola, then the two spots where it crosses the x-axis would be at 0 and -3/4. Okay, number 7 is not in standard form. We need it in standard form. What do I need to do?
Subtract 64.
Okay, so I know I heard it from 2, 5, and I page did you say it? And 3. 2, 5, and 3. So on number 7, I'm going to have x squared minus 64 equals 0. Paige is excited because she, like me, likes these because it's a perfect square. So I'm going to do x plus 8, x minus 8. What are my two answers? Yes, you can have the point for that. Okay, so yes, these are how we factor. Is everyone good here? Is anyone mad at this? So we are going to do x plus 8 equals 0 and x minus 8 equals 0. So x equals -8 and x equals +8. So those are our two answers, yes. But if you're trying to be fancy, you could just put plus or minus 8. Because that tells you +8 and -8. That would be the fancy way to do it. Then you look smart. We're going to skip number 8 for the moment. Why am I skipping 8? I'm not mad at the 9. I'm mad at the 4. Okay, let's go to 9. Can you put it in standard form for me?
X squared minus 4x minus 20.
This is true, so 5. Okay, I need two things that multiply to 21 and add a -4. I understand that, but tell me some signs. Okay, and the reason it has to be that is -7 plus 3 is -4. -7 times 3 is -21. So this is correct. So my two answers are. And if you realize it as quickly as he does, do you actually have to do what I'm doing in the bottom in pink? Heck no. If you realize when you got here that the answers always end up being the opposite sides of that, you're fine. Okay, you handle number 11 and tell me what the answer is. Those are your answers. You can have a point. Yeah, I was going to give a point for knowing what to do first, but I showed it on the screen. So, I'm not going to give out a point for it, but what are you supposed to do first? The GCF of 2. So, did you pull out a 2 out of everybody? Once you pulled out a 2, it became easy factoring. So, you should have 2x squared minus 6x plus 8. Not every term has an x. Okay, then it should be easy factoring because I know two things that multiply to 8 and add to -6. It's -4 and -2. And then if that 2 is bothering you, if you divided both sides by 2, what's 0 divided by 2? 0. So we would end up having just the x minus 4 equal to 0. And just the x minus 2 equal to 0, which is why the answers are 4 and 2. I understand there was a 2 on the outside. But seriously, we can kill him off because we're solving. If we divided both sides by 2, so the 2 died on the left, on the right, 0 divided by 2 is 2. So anytime there's a constant number in the front, literally you can just ignore him. Because if you divided both sides by him, 0 divided by 2 or 0 divided by your number is 0. Is there anyone mad at number 11? Okay, number 8 is where the fun begins. 8. I'm going to do guess and check. And then I'll show you another way if you don't like guess and check. Okay, so we're going to guess and check. But for my first term, I actually have options this time because it's a 4. So I can do 4 and 1, or I can do 2 and 2. We're just guessing what you want to guess. Okay, so let's guess 2 and 2.
Also, I did page 39 and 41.
Can you leave it with me? Thank you. Okay, what multiplies to 9? We can do 1 and 9 or 3 and 3. Which one do you want to do? Okay, so 3 and 3, and then are they both positive, both negative? One of each? Think about that middle term and think about that last term.
So one has to be negative.
They both have to be negative. Because we want it to be a negative in the middle, but it has to be a positive 9 on the end. And again, you wouldn't realize this when you FOILed it out. So that's our guess. We're going to check it and see if we're right. If we're wrong, no big deal. We're just going to change like the 3's to 9 and 1, or maybe change the 2's to 4 and 1. Not a big deal. So we FOIL it out. And this is the exact same speech I gave last period that I feel coming out now. 90% of you are awesome and you pay attention and do what you're supposed to do. The other 10% who play on your phones, again, there's a lesson you're going to have to watch on your own. And you're going to fail the next test, and it's eventually going to kill you in this class. I don't know what math you intend to take after this, but trust me, if you can't handle aptitude trig, you can't go to pre-cal or higher. Lord Jesus, no. That's a terrible idea. So either you've got to decide personally you're going to get it together, or you're just going to keep failing. It doesn't bother me either way. I got to keep doing math regardless. Okay, so I FOIL it out. 4x squared minus 6x minus 6x plus 9 equals 0. Yay, we guessed correctly. So when we combine, that middle is negative 12. So look at you. We guessed correctly. However, now I need the answers. So what are my answers? Say it again. 3 and 3. Yes. 3 halves. Why do I have the same answer twice? Why do I have the same answer twice? Paige, never have I loved you more in my life.
Wasn't even thinking about graphs.
Never. That like makes that was good. Okay. You can have 3 points.
Whoa.
Okay, so y'all know I could have rewritten that as 2x minus 3 squared.
Miss Compton,
Reagan was absent first period. I meant to email you.
that's okay. I need Delaney Williams to check out.
Oh, bummer. Yes, ma'am, thank you.
And who was absent, you said?
Reagan Russell.
Okay, that's okay. I'll get her.
Thank you.
Again.
Thank you. Sorry, Delaney. Okay, so I kind of realized, hey, it's going to end up being the same thing. You don't actually have to write it twice. Writing it once is sufficient. And what that means graph-wise is what pages say. An x-intercept, our graph doesn't have to cross the x-axis twice. It could only cross it once, just at 3 halves. And if it were to only cross once, wouldn't that one spot be the vertex? That was Gina's page. Okay, and then number 10, I need it in standard form, so yes, Ellie, you can have a point. So 15x squared minus 8x plus 1 equals 0. Oh, and I forgot to do the thing I was going to do. She's like a, yes, like a cobra. She's on it. Okay, so back to number 8. If you're hating on guess and check, here is your other option. And if you hate this option, come see me during 0 period and I'll give you a couple more. So our problem was this. There's this method called slide, divide, bottoms up. Slide, meaning we literally slide the 4 down to the end. So we would make it x squared minus 12x plus 36 equals 0. Slide is nice because it slides the thing that was bothering us in the front and moves it to the back And now we're going to have easy factoring. So when I get to divide, really divide just means, yes, I did 4 times 9, yes. So I slid it to the end and did 4 times 9 and got the 36. So the slide makes life into an easy factor. Divide is, I get to do my easy factoring. So multiplies to 36, adds to negative 12. Well, that's negative 6 and negative 6. So that's divide. And the reason I don't do this method is because I always forget the last part, which is bottoms up. And bottoms up means, not what you think, bottoms up means take your number, so our number was a 6 in both terms, and divide it by that thing you slid down. So we slid down a 4, we're going to divide by 4. And then you're like, but that doesn't look like our answer. You're right, it doesn't. We can simplify those fractions, so it'd be 3 over 2. And then never in our life have we wanted it to be fractions like that. So we actually end up moving what was in the denominator to the front of the term. So we'll have 2x minus 3, move that 2 to the front, 2x minus 3. And magically, we've done slide, divide. The hardest part is bottoms up. So I wrote the number, our factor, divided by that thing we slid down, simplified it, move the 2 to the front. This is the part where I'm like, but this makes no sense. But all of a sudden, we have the exact same answer. We have the exact same answer we just got doing guess and check. So if you're painting guess and check, slide, divide, bottoms up works. Okay. Let's move on to back to 10. Good grief. I'm going to do this one guess and check, but I'll also show you slide, divide, bottoms up. So I've got to deal with the 15. Do I want to do 1 and 15 or 3 and 5? Okay, 3 and 5 sounds good. We're just guessing. Okay, I need it to multiply to positive 1. So I know it's a 1. Do I do both positive or both negative? So let's check it out and see if she's right. If I were to pull this out, we would have 15x squared minus 3x minus 5x plus 1, which really is that minus 8x. So she is correct. We did factor correctly. You and I both know we need 2 answers. What are the 2 answers? You can have the point. So our answers are 1/3 and 1/5. Are there any questions about that? But I can do the exact same thing and get the exact same factors if I use this other method of slide, divide, bottoms up. I'll give everyone a second. I see people still writing. No. Keep green. Okay, so here's what our problem was. I want to slide, so I slide that 15 down. I'll have x squared minus 8x plus 15 equals 0. Divide. So I end up doing easy factoring. It's got to add to negative 8. It's got to multiply to positive 15. So negative 3 and negative 5 will do the trick. But now I've got to do bottoms up to get on my nerves. So I've got to do bottoms up. So I'm going to put the 3 over the 15 because that's what we slid down. And the 5 over the 15. I can simplify those fractions. 3 divided by 15 is 1/5. 5 divided by 15 is 1/3. And when I end up moving those denominators to the front, I have 5x minus 1, 3x minus 1, and those are the exact same 2 factors we had when we did guess and check. So if guess and check is not for you, here is a suggestion. If you still can't stand this, again, come see me 0 period. I've got at least 2 more other ways I can show you. But you got to factor something. And then I've never taken the graphing calculator away from Ellie. I just said she didn't need it today, but she can still use it today if she wants to. So she can always graph these on her calculator and make sure those 2 x-intercepts are the 2 numbers she got when she factored. Okay, flip to the next page. So we have one major lesson left, and we're going to finish it between today and tomorrow. The more I can talk today, the less you have to watch tomorrow. Long story short, you and I have discussed how factoring is great, and it will help us most of the time. But what are we going to do when we can't factor? Not like I'm incompetent and can't factor, but like the problem is not factorable. Then what do we do? So we write not factorable is what we've been doing, but we still need an answer. I still need to know where does it cross the x-axis. Just because factoring let me down doesn't mean it didn't cross the x-axis. So we've got to have a plan of what to do with that. So again, it could cross once, it could cross twice, but it could not cross at all. That maybe that's why it's not factorable, because it never crossed at all. Anyway, we've got to have a plan on what to do when factoring lets us down, which is going to lead us to the quadratic formula next week after we take this next test. But before we can handle the quadratic formula, we need to know about something called imaginary numbers, because imaginary numbers help us with the quadratic formula. So basically, long story short, in order for factoring and quadratic formula us to calculate these zeros by hand, we're going to need this next section to help us get there. Okay, so you've heard, we spent a good amount of time at the beginning of the year on different number systems, natural, real, integer, rational, like we talked about those things. However, we didn't spend any time talking about imaginary. We said there were numbers called imaginary. Then we didn't do anything with them. So anytime you see the square root of a negative number, that's when an imaginary number is going to come into play. I know the square root of 25 is 5. I don't know the square root of negative 25. And they noticed this kept happening, these Greek mathematicians. They noticed this kept happening. What do you do when there's a negative under the square root? So they eventually decided to break it apart. And they said, well, what if it's square root of negative 1, square root of 25? I know the square root of 25. That's 5. I don't know the square root of negative 1, but it kept happening so much, the way pi kept happening so often, that they decided to give it a symbol as well. It's I. So I times 5 ends up being 5i. So anytime you're having to deal with the square root of negative 1, you replace it with the letter I. And you do it with a little squiggle too. It's not a straight I. Notice that my eye has a little curve. It's not because I like to do my eyes like that. It's just how they write the imaginary number I. Okay, so looking at our notes, it says the second sentence, not the first sentence. The number I is the square root of negative 1. That is, I is equal to the square root of negative 1. So at the top of my paper, I'm going to put myself a little cute chart. I is the square root of negative 1. And as you can bet, we're going to need to know I squared and some other powers of I in just a moment. Let's just deal with I for the moment. Okay, so number 1, if it was 121, what would the answer be? 11. And because it's got that negative, it's going to end up being 11i. I'll show you how we can break it down. So again, we can do negative 1 times 121. And that's how I'm getting I times 11, which is 11i. I agree. I'm not even going to bother to work it out on number 2. What is the answer on number 2? Paige gets the point. So if it's a perfect square, it's the perfect square number, and then I, because of that negative square root of negative 1. Good Lord. Okay, so what's the answer number 3? Paige gets another point. She remembers her perfect squares. Okay, are there any questions about 1, 2, or 3? I know this is new. It's going to come in handy. I love imaginary numbers. I swear they're so useful. Okay, so we could rewrite number 4 instead of square root of negative 2. Couldn't we do square root of 2i? Because we understand it's really negative 1 times 2. So I'm just saying, we already said square root of negative 1 is I, so why don't I rewrite it as square root of 2i? So how can I rewrite that second term? Square root of 32i. Hey, you're on fire. Okay, so the cool thing about this is it works the way you think it should. We're going to multiply the two numbers under the radical. We're going to multiply the two i's. So I'm going to have square root of 64. And then I'm going to have I to the what power? Yeah, it's just like when you did x times x and got x squared. We're going to do I times I and get I squared. I realize the square root of 64 is 8. I'm going to come back to this problem in just a second. Now for my other little side rant. Back to that chart at the top. Okay, so I squared is square root of negative 1 times square root of negative 1. The square roots end up going away. I squared is always negative 1. I to the cubed is no fun. It ends up being the negative square root of negative 1, and we just call it negative I. And then I to the fourth, because it's really I squared times I squared, it ends up being negative 1 times negative 1, which is positive 1. So yeah, so if we're trying to make this easier to remember, it's I for the first one, negative 1 for the second, negative I for the third, positive 1 for the fourth. So it's I1, I1. I1, I1. I1, I1. And if you want to remember it like that, that's fine. I1, I1. The third doesn't end up being that useful. The fourth is the best. So I1, I1. And yes, you do need to know at least the first thing and the fourth. And if you're going to know the first thing and the fourth, why not know the third? I1, I1. Okay, so back to our problem. Square root of 64 is 8. But I know what I squared is. I squared is. So my answer is 4 and 5 get a point. So number 5, I could rewrite this as square root of 75i times the square root of 3i. I need to know 75 times 3. So I've got square root of 225i squared. So what's my final answer? 2 had it first. 225 is 15. I squared is negative 1. So my final answer is seriously negative 15. I know you're scared of this square root of negative 1. You're scared of this imaginary number. But math works nicely with it. Okay, number 6. 6i times 4i. I get 24i squared. So my final answer is negative 24. 3 and 4. No big deal. What's the answer on the next one? Yes, 4 gets another point. Okay, so hold on a sec, I'll let the others catch up. You're in a league of your own today. Well, I'd say that, Nick, and Paige impressed me for the rest of the day, so. Okay, so we did. He realized negative 3 times 7 was negative 21i squared, but he knew I squared was negative 1, so that's how he got positive 21. And this is where life gets fun. 8 through 11 is where life gets fun. Are you about to leave me? Oh, bummer. 8 through 11 is where life happens. Because anything to the fourth is the best. So, number 8, the answer is 1. Man, you're going to have to watch a video to see the last of those. I got, 2 short of this in first period. So I'm going to start where they ended. So you might have to skip a little ahead. That's fine. I don't know what you do. It's okay if you, don't skip a lot of me, but it's okay if you skip some of me. Especially if you understand